write the equation of the hyperbola centered at the origin with length of the horizontal transverse axis 8 and the curve passes through the point 7, -3. You already see the answers there. How did they find that? How do we go about doing this? Well, what are they talking about? Let's try to draw what it is they're talking about. Let me start with an axis system down here. It's always, a picture is always helpful just to get a feel for what they're even talking about. They're saying centered at the origin, so the middle is the origin right there, and length of horizontal transverse axis. So what that means is that the branches go right and left. How do I know? Horizontal. This is a horizontal line. Right, the one going up and down is a vertical line. So the x-axis is the horizontal line. The y-axis is the vertical line, right? So the horizontal line is the x-axis, and they're saying the x-axis is the one that is the transverse axis. Transverse means the one that cuts across it. It's the major axis. It's the one that cuts across the branches. So they're telling us when they say horizontal transverse axis, they're saying the hyperbola branches go horizontal. They go right and left. They don't go up and down. They're horizontal. They're sideways. So we and the axis with the length of the horizontal axis 8. That means it must be 4 this way and 4 back that way from 0 to make the total length 8. Do you see that? The length of the axis is 8, meaning from here to there is 8. So it must be 4 this way, and it must be back 4 the other way to make the total width from there to there 8. So for the total width to be 8, it's got to go 4 and -4. And it passes through one other key fact. It passes through the point 7, -3. Where's that? 5, 6, 7, down 1, 2. So it's about right there. My graph isn't perfect. 7, -3. Over 7, -3. So they're giving us some point on the ellipse. And whenever they give us a point, in any time in math, whenever they give you a point that is on a graph, you know at some point you're going to plug in the x and the y to the equation to solve for something. That's always how that works. So here we go. Let's start writing the equation. Now that we know the branches go right and left, we know there's x squared in the front, right? If the branches go right, left, x is in the front. If it goes up, down, y is in the front. Minus, because hyperbola always has minus, ellipse has plus in the middle. And we know from the center right and left must be 4. So let's go ahead and make this, well, let me just back up. I'll just do it right there. Just make this 4 squared, because that's underneath x, and that's right and left. Right 4, left 4. From the center, whatever's underneath x is right, left. Okay, and now, what are we going to do from here? We're going to take this x and this y and plug them in. Plug in x there. Plug in y there. Because it's a point on the graph right here. It's a point on the picture. All the millions and millions and millions and millions of points on these graphs make the equation true. That's what any graph is at any time in math. It's a picture of all the dots that make the equation true. So if they give you a dot on the graph, you know it makes the equation true. So plug that in. So what do we got? 7 squared over 4 squared minus, -3 squared over b squared is 1. So now there's only one letter left, b. We can solve that equation for b, and then we'll have the whole formula, because b is all we were missing to have the whole equation anyway. It's all we need is b. So let's solve this equation for b now. This is 49 over 16 minus 9 over b squared is 1. So I just start going to decimals here. Divide 49 by 16 on your calculator. I'm getting 3.0625 minus 9 over b squared is 1. Subtract 3.0625 from both sides there. And these cancel. Bring it on down here. We get minus 9 over b squared. 1 minus that. My calculator tells me negative 2.0625. Now, what do we do when we have a fraction equal to something else? You put it over 1. Remember this? And then you go diagonal, diagonal. Remember, whenever we have fractions that are equal, we cross multiply. So we get negative 9 times 1, right? That's these two multiplying, equals, now these two, negative 2.0625 b squared. Make sure you don't lose that negative there. I began to lose it. There's a negative on that. So, okay. Now we're trying to solve for b here. So what am I going to do? I'm going to divide both sides by the negative 2.0625. Negative 2.0625. Boom, boom. Come on down. B squared equals, so negative 9 divided by, I'm getting 4.3636. It goes on and on. 36, 36, 36, 36, it goes on and on. How do you finish getting b alone? Root it, root it. So b is 2.0. You better use a lot of accuracy here. 2.088993. 2, it's 187, so 2. So that's b. So now we're ready to finish off the equation. We solved for b. So grab the equation. Where was the equation? It was right here with everything but b. So bring that down to this point. And what is it again? X squared over 4 squared. So it was x squared over 4 squared minus y squared over b squared is 1. So now we know what this is. This is x squared over 4 squared minus y squared over b. B is 2.088932 squared equal to 1. And so multiply those on your calculator. If you square that on your calculator, you get 4.3636. Really, that makes sense. We should have just used it from right here, right? Because that's b squared. Of course, that just goes right there. It's b squared. But that's all right. It doesn't matter. We'll just leave it as it is. And so that is our answer. The homework system will take this answer with the decimal like that. Just put a lot of actually. They gave the answer with fractions, 48 over 11. If you divide 48 by 11 on your calculator, it's the same thing. It's the 4.3636. The system will take it either way.